Mathematics 2 Assignment, Parametric Equations and Motion by Dervla Larkin, candidate number D00169820. We're going to now discuss parametric equation of a straight line. So here I have an example where the starting off point is 2 minus 4 and the finishing point is 1224. So we use the equation y equals mx plus c, but since we don't know what m is, we'll have to work that out. So to do that, we do y equals y2, so y2 is 24, subtract by y1, which is minus 4. Divide that by x2, again 12, subtracted by x1, which is 2. And that will then give us, once we work that out, it will give us 2.8. Since we now know what that is, now we can substitute the numbers into the equation y equals mx plus c. So here we are. So y is minus 4, and then m is 2.8 as we worked out, multiplied by x plus c. So minus 4 equals 2.8 times 2 plus c. Minus 4 equals 5.6 plus c. Minus 4 minus 5.6 equals c, so which would get c equals minus 9.6. So that gives us what y is. Now we need to work out what x is. So to do that, we have to work out the time and the difference in time. So that it takes from position 2 to position 12 in 5 seconds. So to do that, we do 12 subtracted by 2, gives us 10, and 10 divided by 5 gives us 2. So that's 10 subtracted by 5 seconds, or no, sorry, 10 divided by 5 seconds. Now we can put that into our equation here. So x is going to be equal to 2t, so 2 times time plus 2, and y is 2.8 multiplied by 2t plus 2 subtracted by 9.6, which shortened down is 2t plus 2 for x and 5.6t minus 4 for y. And now since we got x and y worked out, we can now put it into a table. So I've put time as 1 to 5 down the side, and it gives us this. So as you can see, if I move this up, the first position is here, and as we move down, it works this way down, and it gives us a straight line motion. Now I'm going to discuss wave type form. So here we have t from 0 to 360 in 10 parts. So firstly I did an example of y equals 5t plus 1, and the same x equals cosine t. It doesn't matter if you do x as sine, you can do sine t or cosine t. I chose cosine t. But once we put that into a scatter graph, it forms this. And as you can see, it's a wave. And if I move this, we can see the progression of it. And as you can see, it's forming a wave. And if I just keep going, it gets longer and longer until it gets to 360. As you can see. Now I'm going to continue to parametric equation of a circular motion. As you can see above here, I have an example. An object is initially at 7,2 and it takes 120 seconds to complete a circular motion of radius 4, about the center point 3,2. And as you can see to the left here, I have finished that out, but I've put the time to 120 seconds in just by 1, 2, 3, 4, and continues down. Now to work out x and y, x is 3 plus 4 times cosine t, but what that really means is x equals 3 from the center point here, x, plus the radius 4 multiplied by the cosine of t. And y is the same, y equals 2 from the center point y here, plus the radius 4 times sine the time. And the initial, as you can see, it starts off at 7, 2, which is our initial point from above here. And what that forms, if you continue down, it forms a circular motion chart. And as you can see, if I move this up, we can see that the creation, so it starts here and it just keeps going. And it keeps going until it's in a circle. And it goes over and over for 120 seconds. And forms this graph. For the direction of it, this is going in an anti-clockwise motion. But to change it to a clockwise motion, if you put t or minus here and a minus in here in your answers, it will change the direction. So if I just do that now, just change these. As you can see, now we've started off with more minus numbers, and this chart should change as well. So we'll just see where we can see the difference in the, oh, that's not what I wanted. So as you can see, it's going in the opposite direction. Oh. And that will just continue until it gets to the 120 second mark. Oh. As you can see above, it still creates the same shape but in a different direction.